All right, here's a question where we are asked, say magnesium metal reacts. Yeah. Suppose we have lots of magnesium metal, and we've got a little bit of this stuff, a volume and a concentration of hydrochloric acid, and we collect all the hydrogen in a balloon, and at that temperature and that pressure, what is the expected volume of the balloon? So they want to know what the volume is. Okay, so let's write our equation. So I've got magnesium metal plus hydrochloric acid
I like that.
yields magnesium chloride
Sorry.
aqueous plus hydrogen gas. And this is the stuff we collect. And we know that the temperature of that is 25, so I gotta add the how much? 273.15, so that's 298.15 Kelvin, and the pressure is 1 atmosphere, but I have to do it in kilopascals, so it'd be 101.325 kilopascals. Okay, and they're looking for the volume. Okay, so, and they gave us this information about hydrochloric acid. They gave me a volume of 0.0187 liters and a concentration of 3 moles per liter. So this question will be one that's going from a liquid, that's this stuff, to moles, and that's moles of HCl, convert to moles of hydrogen gas, and then it's a gas thing, so convert to a volume in a gas. Okay, notice it's not a limiting reagent question because they didn't give us any information about this. They just said there's excess of it. So you have lots, therefore that's your limiting reagent, and you don't have to do anything to figure that out. And so we're going from there to there. All right. So step 1, let's convert the concentration and volume to moles of HCl. So we're doing step 1. Okay, concentrate. My formula is moles is equal to C times V, I believe. Yeah, and so the concentration is 3.00 moles per liter times the volume 0.0187 liters. Liters cancel, so I'm going to do that on my calculator. So I get 3 times 0.0187. And I'll keep this number in my calculator, 0.0561 moles. Okay, that gets me right to there. Now let's do step 2, get across the river. So I want moles of HCl, and we're going to convert that to moles of hydrogen. So I write what I have, 0.0561 moles times, well, I didn't balance the equation. Whoops. There's a 2 here. I think that balances it, doesn't it? 1 magnesium, 2, yeah. I think that balances it. So what I want is moles of hydrogen. So it's 1 mole hydrogen, and I have 2 moles HCl. So these cancel, so I divide that number by 2, and I get 0.02805 moles of hydrogen. Now I need to do step 3, that's this one, and that's my PV equals nRT stuff. So just move that up a bit. So PV equals nRT, so I'm going to take the moles, the pressure, and the temperature of hydrogen and convert it to volume of a hydrogen. So our formula is PV equals nRT, and I'm looking for volume, so volume is equal to nRT over P. Moles I just have right up there. The R value is 8.314 0.44 kilopascal liters per Kelvin mole. The temperature is 298.15 Kelvin, and the pressure is 101.325 kilopascals. So the kilopascals cancel, the kelvins cancel, and the moles cancel. So let's times that all out on the calculator. So I have that one already. So times 8.3144 times 298.15 divided by 101.325 equals, so 0.68649, etc. liters. And if I wanted to convert that to milliliters, I'd go over 3. So 686.249 liters. And if I want to do sig figs, I think in the question I had 3 everywhere, right? So I should write it as 686 liters. That's a whole lot of volume of gas. And how much did we start? Oh, we had, no, what did we start with? 18 milliliters of a 3 molar solution. So that's quite a bit of, quite a volume. And that's, what?
Is that on Bluetooth?
No. Yeah, that's quite a volume. Okay, hopefully that helps you with that question.